all these satellite data to generate elevation models. As you might know, we have the SPOT family, the SPOT satellites. We have Pleiades satellites, 2 of them. We have our radar satellites, so Terra X and Tandem X data. We using these data sources, and by applying different technologies, we generate elevation models on different levels. When do you need elevation models? So here we are talking about mapping. Everybody knows to create a map, you need the elevation, the height information for contour lines or for single height information. So to create any maps, no matter what, you need the elevation. Very important input is it also for auto rectification of other high-resolution satellite data or aerial data. Of course, for preparing all missions, for flood modeling, for all the modeling what happens on the surface of the Earth, you always need to know the height differences and the absolute height information. Maybe also to mention what's here on the slide on the last bullet is really that in the meantime everybody expects to see 3D visualization stuff. So fly through, for example, you always need this information. And of course, depending on the application, the level of detail is key. With our so-called GEO elevation suite, we can provide a very comprehensive portfolio when it comes to elevation model. So we call it after the pixel size or posting pixel spacing. So we have an elevation 30 product, that means 30 meter posting, elevation 10, elevation 4 and 1 meter at the moment in our portfolio. I would like to give you more details on these 4 products. Elevation 30 is based on SPOT 5 satellite data. The strategy is to build up a database. So in the meantime, we already have more than 70 million square kilometers worldwide in our database. The vertical accuracy goes down to 8 meter, and the horizontal accuracy can be up to 5 meter. This is a so-called DT2 level product. You might be familiar with that standards. And of course, with the elevation model, we also can offer the auto-rectified image data we are using for generating this elevation model dataset based on stereo approach. Here an overview where you can get data right off the shelf. This is a big advantage. So all the red areas are available off the shelf. So that means if there is a need, just call it, and after 2 days we can deliver the data. And the green areas, we already have prepared data in the archive. We just, if there is a request, we just need to produce elevation model out of it. And even for these purple areas, we have already validated area in the archive, but this first would be that we have to apply a feasibility study to it. But the red areas you could get right away. The next product we have is Elevation 10 product. This is based on radar data, on the Terra X data, using radar grammetry technology for that. 10 meter grid spacing is already mentioned, and an absolute height accuracy down to 5 meter. And this is called it's a product of the HRTE3 or DTIT level 3 product. In this case, we are offering 3 different product variants, we call it. So we have the DSM, the surface model, that means including the height of the buildings and also the vegetation. We also have an DSM where we edit the water bodies. That means that the lakes are flattened to 1 elevation height, and for the river we ensure that they flow downhill. Additionally, we also offer a DTM, that means a digital terrain model representing bare earth. So that excludes the height of the buildings and the vegetation. To show you the difference, I'm not sure if I have a mouse here. Yes, this is the city of Barcelona. Here you can maybe see the ocean shoreline. This is what we call the DSM Basic. There is no water body editing applied to, so it's sometimes difficult to see really the shoreline. In the next example, you can see that the ocean is flattened. We use a geoid model, so that means, as a reference, that means that the ocean is set to the height of 0. And also some other water bodies, maybe it's hard to see at the moment here, are flattened. And the DTM, as I said, we remove the vegetation and the buildings. That means that you cannot see any city structures here anymore, as you can see here. Of course, you see some of these highway tracks, but this means that they are really, these are not bridges or something, but they are really connected with the ground, and that's why it's, let's say, part of the bare earth. The last, or the next two elevation models we providing are based on our Pléiades data. We have 2 Pléiades satellites in the orbit already, and that's very comfortable because the data acquisition rate is very high, and they are very agile, so we can really cover an area very fast with that. One product is produced in 4-meter grid elevation model with an elevation or height, vertical accuracy of 3 meters. And the elevation 1 product, as the name says, is 1-meter grid product, and the elevation height is down to 1.5 meter. The last one, elevation 1, is more specified for open areas and not very dense urban areas. Here I would like also to show you some examples later. First, I want to point you to the big advantage we have with our Pléiades data. We cannot just only acquire data in stereo, but we also can use a 3-stereo approach. Now the question is, when do we need 3 images, when our 2 images are enough? So this is the decision we make within a feasibility study. To illustrate that, if you have an area like in this we have buildings, or it also can be steep slopes that you cannot really see, let's say, behind the slope, it's always good to have the 3 different look directions. If you just have 2 in this example, the orange area will not be covered or detected or measured. If you have these 3 look directions, even in this steep valley, you can cover the area and the slope. And this is shown in this in the 3 examples down here. So we built always stereo pairs. So in the first one we used image 1 and 2, then 1 and 3, and in the final version we have final example we have image 2 and 3. And finally we combine it together, and the red areas showing actually the areas we cannot see in the data because they are, let's say, behind an object or in the shadow of an object. They are very impressively reduced actually in the final product we will use, and we will apply editing to it. So the most important, or the important thing here is we really can get rid of a lot of hidden areas or which lead or come up actually to voids in the data set. So even in an area here like downtown Melbourne, we have a lot of data available and do not have to deal with a lot of voids. Here are 2 examples, one on the left-hand side for elevation 4, on the upper part, we always have the ortho image, and lower part shows the elevation model. You can see here buildings, and of course here the infrastructure, the roads, pretty easily. In elevation 1, we can really see the form and the shape of the buildings, and very detailed, even small infrastructure is represented in the data set. More to elevation 1, because it's really very impressive how many details you can detect here. This is the ortho image. You can see here is a mountainous area going downhill to an urban area, and here we also have an airport. When we have a look to the elevation model, which means also surface model, of course, you can see that even on both sides, that means in steep areas on the left-hand side, but also in flat areas, you really see all the details. And zooming in a little bit, coming closer to this part here, you even can see here we have an industrial area where we see these tanks. And these are tanks which are moving a roof. So that means if the tank is empty, the roof is at the bottom. And is it filled, the roof goes up and covers always the tank. And here we also can see even 2 empty tanks there where you just can see the ring outside. So it's a really very detailed information we get in the data. And just for fun, let's zoom into these aircrafts here. You even can see exactly the shape of the aircraft, and also know the type of the aircraft if you have additional information or are an expert in that. This is our Elevation 1 product. What we also are going to offer is a DTM in the future. This is, as I said, the DSM here in highway and urban areas, here more industrial areas with bigger buildings. And the DTM will remove all these city structures from the elevation model. An overview and a summary of the products we provide at the moment. You can see from the left to the right side that it goes always finer, the resolution gets finer, the accuracy goes higher, and it's more precise. And we provide one product really off the shelf, so that we really can say we have a big portion, assuming that the world is 150 million square kilometer land mass. So half of it is right off the shelf available, and the other 3 products are available on demand. The advantage here is that you always get fresh data and the latest information. So depending on the request and on the needs, we can really support your applications. So if you need something very quickly, then definitely off-the-shelf product is the right answer. If you need fresh data because there was any event, let's say a tsunami or so, and you need to know about the coastline, then of course the other products where we can do the data acquisition right away is the right answer. If you have an area in, for example, tropical belt or clouded areas, then it's good to use the radar data, because here is ensured that the data acquisition is on time, because as you might know, that radar is not affected by the clouds. They look, let's say, through it. Terrain model we already provide, or also provided on 3 different levels. We have 4 different accuracy levels in our portfolio, and we also have to say, if the budget is limited, and this is very often the case, of course, we also have a very good pricing actually for our off-the-shelf product Elevation 30. This is, by the way, the list price, I have to say. Now I want to do a step in the future, and I want to say in the near future. Maybe you heard about the Tandem X mission from the German Aerospace Agency, from DLR. two satellites, Terasa X and Tandem X, the two radar satellites, are in the orbit in a formation, not a constellation, and a formation, flying with a certain distance between each other and collecting data over of the entire landmass of the Earth, starting in end of December 2010. The goal of this mission is to produce a worldwide elevation model. And this is really a unique mission. So the plan is that within 3 years, the world will be covered at least 2 times per point on Earth. So in areas where we have difficult terrain situations or so, we will have 3 or 4 coverages. So the 2 satellites collecting data, that means one satellite is sending the radar beam. Both satellites are acquiring receiving the signal, and based on interferometry technology, the elevation model can be produced. Our company is the company who will sell this product. We call it the World DEM. So we will get the data from the DLR, from the German Aerospace Agency, and will commercialize them. The products are similar to what we offer so far for Elevation 10, which is also radar-based data. We will have a surface model. This will be available worldwide. That's the strategy behind that. But for certain spots, also DTM can be provided, because for many applications, DTMs are required. The accuracy is, I would say, amazing if you think it's worldwide. So we have a vertical accuracy absolutely better than 10 meter and relatively better than 2 meter in flat terrain, and better than 4 meter in areas with slope more than 20%. Especially if we think that this could really become a foundation layer, a layer where we reference all the other data when we work in a GIS system, for example, then this accuracy is really amazing for a worldwide elevation model. Important to mention is that the grid spacing will be about 12 meters. Oh, time. Yeah, I hurry up. I skipped that because I want to, at the end, definitely show you one example. Here we have the radar image of an area in Minnesota. So you can see here an urban area, and here we have infrastructure. So here are the roads. Here is a road going, and here we have a highway crossing the other roads. This is an elevation model, SRTM 90 meter. I guess everybody is familiar with that. It's available for free. This is SRTM 30 meter. This shows the much more details already. And the next is our upcoming World DEM. And here you really can see even up to this intersection here, so the exits and all the fine structure in the urban areas here. It's really a big step. It sets a new standard, actually. Thank you very much.
Спасибо. Спасибо, Gertrud.
Thank you, Gertrude. Thank you for staying within your time frame. I'm sure there will be a lot of questions to you. It was a very interesting but also dangerous presentation. Let us hear questions now. Don't you think that this woman is going to steal our work from us? Because very soon she's going to acquire the digital elevation model of the whole globe. All we have to do is get her email address and ask her for this product, and she will just cut away a portion of that, and we won't have to use our aircraft to do that. Any questions or comments? Thank you very much. Sergey, would you like to? Okay, you can ask the question. I'm sorry. Thank you. Thank you for a very interesting presentation. Tell us, please, briefly. I will skip the motivation, but can I buy World DEM for the whole Russia, World DEM 04? Or, and the second part of my question, have you attempted before to restrict coverage of this model to some areas of some countries because it is related to some international conflicts or I don't know, some whatever, maybe some other countries didn't want you to cover all areas. I thank you for your question. I'm sure that everybody has a question similar to that.
Yeah, thank you very much for the question. It's a very good and fair question. Overall, there are no restrictions. What we have, and I think I can mention this, that EADS, so Astrium is an EADS company, we have an export control. And here, of course, it's important to know the customer and the application. This is standardly proved by, in our process. Yes, there is something, but I see no problems if somebody comes and wants to have Russia at the moment. So, should be possible. I unfortunately cannot say when exactly next year Russia will be available. Maybe I should mention this, that the data will be delivered from DLR to us, to Astrium, starting beginning of next year. You can imagine that is an unbelievable amount of data what will be shipped from DLR to us. And so this takes time, but Russia will be available next year, and I'm very happy if there's interest in the data from your side.
Спасибо. Еще вопросы, пожалуйста.
Thank you very much. Will there be more questions? Your question, please. Ну, без... I think TerraSAR X expiration date is in a number of years, right? How can it affect the whole program? And do you have plans to launch new satellites in future?
I have to ask back, you're talking about the TerraSAR X next generation or TerraSAR X2?
No, I'm saying that now there are two TerraSAR satellites. One was launched a long time ago, and it's going to expire soon. And there will be no grouping, no formation, as you said, anymore. And what are you going to do then?
Thank you very much. Good question. Yeah. So the good news is that both satellites, one was launched in 2007 and the other in 2010, are in a very, very good shape. So that means that the fuel is enough even to extend this formation if required, if requested. The other thing is, of course, we are thinking about a next TerraSAR X generation, where we want to come down even to centimeter resolution. And but this is, let's say, at the beginning, in the test phase, and this depends on many things. So unfortunately, at the moment, I cannot promise that we will have in 2016 a next generation of TerraSAR X satellite, but we are working on that. And we will see it, as you can imagine, it also depends on money finally or on the time. So, but we are definitely working on this, and there is interest in that, yes.
Спасибо, Gertrud.
Thank you, Gertrude. Please don't leave. Please stay with us. I'm sure there will be many more questions during the coffee break and during dinner. One will dance with you. I'll have a lot of questions for you. Thank you. No more time for questions, although I enjoyed your presentation immensely. So let us make friends with Gertrude, because she is going to be a major, major provider in future.
To answer your questions.
Да, следующий докладчик.
Yes, and the next